Algebraic patterns, part 3. Consider the following pattern. So if we have 4, 7, 16, 31, 52, 79, ... The first difference is 3, 9, 15, 21, and 27. So 4 plus 3 is 7, plus 9 is 16, plus 15 is 31, and so on. We notice that the first difference is not the same. Therefore, this pattern or this function is not linear. It will not form a straight line. So then we have a look at the second difference. To get from 3 to 9, we add 6. To get from 9 to 15, we add 6. To get from 15 to 21, we add 6. To get from 21 to 27, we add 6. We can see that the second difference is the same. Therefore, this will form a quadratic function. Because the second difference is constant, we know this is a quadratic pattern of the form ax squared plus bx plus c, where x is greater or equal to 0 and x is an element of the natural number set. So when x is equal to 0, we get ax squared plus bx plus c is equal to 4. Therefore, c is equal to 4. So let's have a look and see why that is. So replacing each of the x's with a set of brackets and putting 0 into the brackets, a times 0 squared will cancel, and b times 0 will cancel, and that will leave you with c is equal to 4. So c is equal to 4. If we then choose our x value to be 1, we get ax squared plus bx plus 4 is equal to 7. So where did we get the 4 and the 7 from? Well, we know from the previous slide that c is equal to 4, so we worked that out already. And if our first term is 4, our first term had an x value of 0. So when that ax squared, when that x value was 0, and the bx, when that x value was 0, they cancelled and we were left with c is equal to 4. So for the first term, always in our pattern, our x value is 0. And don't get confused with the nth term, where t1 is always term 1. So we input 1 for the first term. This is different. This is to do with the equation and the function itself. So if we are subbing into our function, so not our nth term, now into our function, our first x value will always be 0. And what happens is the x squared term will cancel, the bx term will cancel, and you'll be left with your y-intercept. And in this case, the y-intercept is 4. So 4 is our first term in the pattern. So if x is equal to 0 to generate the first output or the first y value, then x is equal to 1 will generate the second. So when x is equal to 1, we have ax squared becomes a times 1 squared, plus bx, which becomes b times 1, plus 4, and that's going to be equal to 7, because 7 is the second term in our pattern. And a times 1 squared is going to be 1 squared, so that's just 1 times a, which is a, so that's where that a comes from. And b times 1 is just b, so we get a plus b plus 4, because we know that our c is 4, is equal to 7. So we have a plus b plus 4 is equal to 7. So a plus b is equal to 3, because 7 minus 4 is 3. So we do the same now with x is equal to 2. So we have ax squared plus bx plus 4 is equal to 16. So again, the 4, the c part, we worked out at the start. We worked out c to be 4. That's the first term of our pattern. And we let it equal to 16 now. So remember, x is equal to 0 for the first term, x is equal to 1 for the second term, and x is equal to 2 for the third term. So x is equal to 2. We get ax squared plus bx plus 4, because we got c to be 4, equals 16. So we have a times 2 squared, because we're replacing x with 2, plus b times 2 plus c is equal to 16. A times 2 squared gives us 4a, because 2 squared is 4. So the 2 gets squared, 2 times 2 is 4, and that's multiplied by a. So we don't get 4a squared here, we just get 4a. Then b times 2 is 2b. We know the c is 4, we worked it out at the start, and again it's equal to 16. So simplifying, we get 4a plus 2b is equal to 12, because 16 minus 4 is 12. So now we're going to solve simultaneously. So we have a plus b is equal to 3, and 4a plus 2b is equal to 12. So solving simultaneously, we want either the a's to be or the b's to match and to be opposite signs. So I'm going to multiply the top equation by minus 2. So I get minus 2a minus 2b is equal to minus 6. The b's will now cancel. So 2a is equal to 6. So a is equal to 3. And solving for b now, so we take one of the equations and we sub in a as 3. So we have 3 plus b is equal to 3. So b is equal to 3 minus 3. So b is equal to 0. So solving, we find a is equal to 3 and b is equal to 0. We worked that out in the previous slide. Thus, the pattern can be represented by the polynomial function f of x equals 3x squared plus 4, because ax squared plus bx plus c is equal to 3x squared plus 0x plus 4, which simplifies to 3x squared plus 4. So the 3 came from here because we worked out a is equal to 3. And the 0 came from here, we worked out b is equal to 0. So the 0x will just cancel. So you're left with 3x squared plus 4. So that's our function. And the function represents this pattern. The pattern is 4, 7, 16, 31, 52, 79. And if you wanted to graph it, you would use this function. So f of x equals 3x squared plus 4. So our second difference worked out to be 6. And 6 divided by 2 is 3, which gives us our a value. So this is something that you'd want to learn off by heart. If f of x equals ax squared plus bx plus c, the second difference will always be equal to 2a. So 2 multiplied by a. So if the second difference is 6, then 2a is equal to 6. Therefore, a is equal to 6 divided by 2, which gives us 3. So if you ever want to know the a value of your function, so the coefficient of x squared, you just half the second difference. So this is a rule. For quadratic patterns or sequences where the second difference is constant, i.e. the same, the second difference is equal to 2a. So if f of x is equal to ax squared plus bx plus c, the second difference is equal to 2a, i.e. divide the second difference by 2 to get the value of a in the equation or function. F of x equals ax squared plus bx plus c. So learn this off. It's very, very important. Example 1. Examine each of the following patterns of numbers and determine if there is a linear or quadratic relationship between the terms. Write an algebraic expression for each set of numbers. So part A, minus 2, 1, 4, 7, ... So I'm going to start by just writing out my pattern. I find the difference between each term. So to get from minus 2 to 1, I'm adding 3. To get from 1 to 4, I'm adding 3. To get from 4 to 7, I'm adding 3. So since the first difference is the same, I know that the pattern is linear. So if I was to draw this pattern out graphically, it would form a straight line. So f of x is equal to ax plus b for linear functions. So we get f of x equals 3x minus 2. So the 3 is the coefficient of x. So that's the first difference. So that's equal to the slope. So the a becomes 3. And then the plus b is minus 2. It's the first term of our sequence. And if we were to draw this out graphically, that would be the point at which the line cuts the y-axis. So that's known as the y-intercept. That's the first term of the pattern. So we say f of x equals 3x minus 2, where x is greater or equal to 0, which means where x is greater or equal to 0. So drawing this out on a graph, we would get a straight line, and we can see it has a positive slope. So 3 is our slope. So our coefficient of x is always our slope. So we can see it's going uphill, and it's crossing the y-axis at minus 2. So if you want to draw this pattern out graphically, this is what it will look like. So then B, we write out our pattern, 3, 5, 11, 21, ... We find the difference between each term. We get 2, 6, and 10. That's the first difference. So our pattern is definitely not linear because the first difference is not the same. So then we get the second difference and it ends up being 4. So it must be quadratic because the second difference is the same. The second difference is constant, so the pattern is quadratic. So our function is in the form of f of x equals ax squared plus b. So it's a quadratic function. So 2 times a is equal to 4. So a is going to be half of 4. So 4 divided by 2 is 2. So to work out the coefficient of x squared, we just divide the second difference in half. So half of 4 is 2. So now we know what our a value is. So our function is f of x equals 2x squared plus b. And then to find what our plus b is, we just take the very first term of our pattern, which is plus 3. So our function is f of x equals 2x squared plus 3, and the plus 3 is the y-intercept. So we say f of x equals 2x squared plus 3, where x is greater or equal to 0. And drawing this out on a graph, we get a U-shaped graph because it's x squared. Our highest power of x is 2, so it's a U-shaped graph. It's positive x squared, so it's positive 2x squared, so that's why it's a U and not an N. If this had a minus in front, it would be an N-shaped graph. And our constant is plus 3, so it cuts the y-axis at plus 3. So this is what it would look like graphically. So the pattern 3, 5, 11, 21, drawn out graphically, looks like this.